In the diagrams below, resistors R1 and R2 are shown in two different connections, a series connection and a parallel connection. Which has the greatest current running through the battery? So there's a couple ways that you can approach a problem like this. You can either do it fully conceptually, if you remember some things about circuits, or you can easily do it mathematically as well. We'll do mathematically and then explain it conceptually afterwards. So what we can do is we can just go ahead and calculate the current in both of these scenarios. To do that, we first have to make a couple of assumptions, or we have to assign a couple values to our resistors. So let's just say that R1 and R2 are both equal to 2 ohms. And let's also say that the electromotive force and the voltage on the battery, which are the same, is also equal to a value of 2. Okay, so when we're adding up resistors in a series circuit, we add them linearly, right? The total resistance is just R1 plus R2. So if we have R1 and R2 equaling 2, 2 plus 2 gives us 4 ohms for the total resistance. Then we can use Ohm's law. V equals IR. Let's do a little line here. And solve for the current I, which is V divided by R. The voltage we've determined is 2 volts, and the resistance we just found, the total resistance, RT, is 4 ohms, so the current is 1/2 amps. Let's go ahead and do the same thing to a parallel circuit. In a parallel circuit, resistors add as the reciprocal. So 1 over R1 is 1/2 plus 1/2, which is just going to be equal to 1. And if we cross multiply, we will have RT equals 1. Now we can go ahead and find the current using Ohm's law in the same way we did for the series circuit. Voltage is 2 and the resistance is 1. So we get a current of 2 amps. We can clearly see now that the circuit with the greatest current is going to be the parallel circuit. Okay, so we figured that out mathematically. Conceptually, you can understand this question by recalling that if you add a resistor in parallel, what that's going to do is it's going to overall increase the current in the circuit. And if you add a resistor in series in a circuit, you're going to decrease the current. If you think about it like vehicles on a road, the classic analogy, in a parallel circuit, adding an extra road means that the cars are going to be less congested. There's going to be less traffic. In a series circuit, if you add more cars, or you make it harder to drive by adding a resistor essentially, then there's going to be more traffic. So the parallel connection has the greatest current running through it.